Welcome. In this short lesson, we will understand what a systematic review is, why it matters in healthcare, and how a student can begin one correctly. A systematic review is not simply a long literature review. It is a planned and transparent method for finding, selecting, checking, and summarizing all relevant studies that answer a focused research question. The key idea is simple. We decide the rules before we know which results we like. Imagine that our question is, do smartphone-based health applications improve blood sugar control in adults with type 2 diabetes? Before searching for individual studies, we first ask a more basic question. Has this topic already been reviewed well? This is called the evidence gap check. We search for recent systematic reviews, meta-analysis, and protocols. If a recent high-quality review has already answered exactly the same question, we should not simply repeat it. We may need to refine our question, update an older review, or choose a different topic. Once the review is justified, we structure the research question. For an intervention review, PICO is commonly used. P means population. In our example, adults with type 2 diabetes. I means intervention. Here, smartphone-based mobile health applications. C means comparator. For example, usual care. O means outcome. Here, an important outcome may be a change in HbA1c. Once the question is clear, the next step is the protocol. Think of the protocol as the blueprint for the entire review. It specifies which studies can be included, which studies must be excluded, which databases will be searched, how screening will be performed, what information will be extracted, what the primary and secondary outcomes are, how risk of bias will be assessed, and how the evidence will finally be synthesized. The protocol should be prepared before the final results are known. Next comes the literature search. A systematic review should not automatically depend on PubMed alone. The databases we choose must depend on our research question. Depending on the topic and available access, relevant sources may include Medline or PubMed, Central, Embase, Sinahall, PsycInfo, trial registries, and other specialized databases. Citation searching may also identify additional studies. When building a database search, related words within one concept are usually connected using AR. Different concepts are then connected using AND. We may use controlled vocabulary such as mesh terms in PubMed together with ordinary keywords. We must also record the exact search strategy, database, and search date. Why? Because another researcher should be able to understand and reproduce what we did. After searching, all records are brought together and duplicates are removed. But duplication is not always simple. The same study may first appear as a conference abstract, later as a preprint, and finally as a journal article. Several publications may therefore represent one underlying study. Screening then usually occurs in two stages. First, titles and abstracts are checked. Second, potentially eligible articles are examined in full text. Ideally, two reviewers make these decisions independently. When they disagree, the disagreement is resolved through discussion or, when necessary, another reviewer. During full text screening, every excluded article should have a clear reason. For example, wrong population, wrong intervention, wrong study design, or wrong outcome. These numbers and exclusion reasons later become part of the PRISMA flow diagram. PRISMA is a reporting guideline. It helps researchers report clearly what they searched, what they screened, what they excluded, and what they finally included. Prisma does not turn a poorly conducted review into a good one. Instead, it helps readers see whether the review process was transparent. At this stage, we have moved from a broad research idea to a clearly defined group of eligible studies. The next questions are: what information should we extract from those studies? How do we judge whether their results may be biased? And when is it scientifically reasonable to combine the results in a meta-analysis? That is where the second part begins. The main lesson from part 1 is simple. A trustworthy systematic review begins with a genuine question, a pre-specified protocol, an appropriate and reproducible search, and transparent study selection. The researcher follows the method. The researcher does not select only the evidence that supports a preferred conclusion.